In this episode of Cube FM, I got a chance to speak to Artem. We've also had on the podcast previously speaking about surviving multi-tenancy in Kubernetes. But in this episode, we focus on the intricate challenges of observability in Kubernetes environments, examining why traditional observability frameworks often fail in the context of Kubernetes. We get up close with the inherent complexity of Kubernetes clusters, the limitations of relying solely on metrics, logs, and traces, and the necessity of context-aware observability tailored to dynamic, ephemeral workloads. Our conversation touches on the relationship between observability and control planes, the impact of Kubernetes distributed architecture on data collection, and the tools and techniques needed to improve system visibility and reliability. This episode is sponsored by LearnK8s. LearnK8s is a training organization that has helped engineers level up since 2017. Trainings are given both online or in person. They are instructor-led, are 60% hands-on and 40% theoretical, and students have access to the material for the rest of their lives. For more info, check out learnk8s.io. Now, let's get into the episode. Artem, welcome back to Cube FM. Pleasure to have you with us. First question, which 3 emerging Kubernetes tools are you keeping an eye on?
Hey Bart, thanks for having me again here. Another day, another topic. I'm happy to be here. Which 3 tools? If I remember it right, the first time I said Kyverno, Cert Manager, and Argo CD, and it's still there. The only thing that I am not really changing, but I try to replace Argo for some customers with Sveltos, because this year I discovered Sveltos, and I have a lot of struggle with Argo CD. If you have a lot of applications, reconcile, try to sync them all. So you have a lot of resources going up, and I try Sveltos. Sveltos is an add-on controller. In simple terms, this means it allows you to deploy application across different clusters, like with Argo CD, but based on cluster profiles. And the biggest difference is that Sveltos deploy agents on the managed clusters, and the agent tells the management cluster, hey, if something goes wrong or if you have a delta, so sync please. And it also allows you things like I struggle to see a lot with pod security standards. Argo CD don't allow you to install Helm charts or to template Helm chart and then to patch them. And in Sveltos, you can define something like, for example, you first template via Helm chart and then you patch with customize, because for a customer of mine, they needed a lot of security context, and a lot of third-party tools don't provide it. And so, yeah, Sveltos is maybe a good alternative for not every customer, but I try to play with it. So this is the only things that change.
Okay, very good. Now, we know that you were on a previous episode, but for people who don't know you, can you tell us a little bit more about who you are, what you do, and where do you work?
Yes, my name is obviously Artem Laiko. At the moment, I'm wearing the title platform engineer. It changed every time, and from the last time, I'm also now a Kubestronaut, earning the 5 certificates you need to get the title from this year. And I try to build solution based on open source that simplifies the lives of many. Then I package it in blocks and try to generate some traffic for the tool so they get more contribution from like me. And at the moment, as I say, I work as a platform engineer for IITS Consulting. It's a service provider specialized in software development, platform engineering, and AI. But the real AI, not the AI hype, started 2 years ago. So we have real AI engineers and PhDs.
Good. And in your case, how did you get into cloud native?
It started at the university. I had a project to make GPUs fairly usable for different users. For deep learning, it was, if I remember it right. And then when I come to contact with Docker to make it possible to write a wrapper script and use Docker for that. And after that, I ended up with Minishift, OpenShift, Managed Kubernetes, and somehow stayed there like a prisoner in the cloud native world. Maybe something like Stockholm syndrome or something like that.
Good. And what were you before cloud native, before the Stockholm syndrome kicked in?
To be honest, it's like I was born in the cloud native world. It's still there. I was a student. I was a student in the hardware engineering field who did with a lot of microcontroller, FPGA boards, and all the topics you have limited memory and to handle it. And then I'm enjoyed or joining the dark side from cloud native and still there. So I was not something like a software engineer before, something like that. from student directly born into the cloud native world.
All right. Now, you recently changed jobs. In your previous role, you were fighting multi-tenancy. How does that compare to your current role?
It's compared now. It depends a lot on the customer I'm working with, and also they need challenges to be solved for the customer. One current topic is what I'm working at the moment is internal developer platform, the hot topic, how to build it. Do I need one? Which value would be generated? Something like that. This is the moment I'm working on it. Also, internal developer platform, build or buy. But also how I can integrate AI in the everyday life of the developers to solve various challenges and how to troubleshoot, for example, your infrastructure. We have our own product for this part because if you are working for German companies, they can't use OpenAI or something like this, and then you need to integrate a sovereign solution, and we try to integrate it into the everyday work life. So, for example, if you have some cluster issues, I don't know if you're familiar with tools like Homes GPT. It's need a backend, so you can say, "Hey, help me with my cluster, which issues I have," and then he's running and say, "Hey, so and so, you have to solve it," and we provide the backend based on your documentation. So ChatGPT don't know your infrastructure, but you can provide it. So this is also what I'm working a lot on it. And it's like a lot of fun because it's really fast and the answers are scary good.
Now, as part of our monthly content discovery, we found this article that you wrote titled Black Box versus White Box Observability in Kubernetes. So we want to dive into this a little bit deeper. Let's start with the basics. Observability is a term that we hear in the Kubernetes world, but it seems to mean different things to different people, despite the fact that we hear it, all the time. How would you define observability and why is it so crucial in modern systems?
This is a good question, and I think it's tough enough to crack. In my opinion, observability is buzzwords that often use when you don't know exactly what you want to cover. Something like you put on GitOps, on DevOps, and for me, it's something like that. I try to describe it like observability. It allows you to see what happens in your cluster. So you have something matrix. Then it allows you to see why it happenings in your cluster. You have something like logs and traces, and also it allows you to see how you could prevent it. It's a new topic. It's profiling. It's not basic. It's very advanced, and the most people don't hear about it. But so you can see why it's happening, and it will also inform you if something goes wrong. This is the alerting part. This is how I try to explain it. If someone asks me, "What do you want? What is observability for you?" These are the key points I want to reach with observability. And I also think if you want to know what's going on in your system, you should use it. But that's also the point. Most people know what they want to know and think that tools like Grafana and Prometheus are enough, but they are not. So
You just mentioned, Prometheus and Grafana. There's a common perception that setting up these tools is sufficient for observability. Can you explain why this might be an oversimplification?
I can try. If you deploy Grafana on Prometheus, then you only allows you to see what's happening in the system. You only have metrics and a default dashboard, or maybe some default dashboard. So you know maybe that the CPU utilization of your application was high, and then or you what is the point to knowing that the CPU utilization was high last week? You don't know the cause, you don't know the context. You have just a grid dashboard with a matrix that says your CPU utilization was high, and I think this is not solve any problems. And because of that, there's oversimplification if you're just only using Grafana and Prometheus for the most use cases. Of course, you have edge cases where they works, but for the most use cases, you not created value.
In your article, you introduced a three-layer observability model. Could you walk us through these layers and explain why you've structured it in this way?
Yes, of course. I describe the top layer as an external layer because for me, this is where the external calls happening. For example, to see whether the website like Google, for example, is still available if I call them. This is for me the external layer. Then I describe the second layer as an internal because it represents the view of the application like logs, metrics, and going more inside. And then I have also mentioned OS level observability, focuses on monitoring the system calls and kernel level events, which is very crucial for security and deep performance insights for different teams. This means that when a service owner, for example, or what was the reason behind, I try to explain everything simple. And for example, this means for me, when a service owner comes to me and says, I want observability, I know this usually means the accessibility of his application from the outside in order to fulfill, for example, SLAs. And this is for me the external observability point, the layer of external. When a developer also come to me and says, I have observability or I want observability so that I can see when my application is no longer running properly, then I know he often means he wants logs, metrics. He's speaking about something like this. So this is the internal layer. And if someone comes from the platform team or the security comes to me and say, I want observability to see if unwanted activities are being carried out, then I know he means something OS operation like syscalls. And as you can see, everybody comes to me and says, I want observability, and you need to make a difference how to speak with different stakeholder. And because I established this model for me, and it helps a lot to speak with different stakeholder, understand their needs, and then deliver the right solution.
Let's take a closer look at the first layer, external observability. What does this layer encompass, and why is it considered separate from internal monitoring?
For me, if this is the focus of such tools is monitoring the ability and performance of an application services from the perspective of an external user. For example, if we are opening a site like Google or something, another site, it's have inside for me availability, checking whatever service is reachable at all. Also, the response times is a key metric you need. For example, measuring how quickly the application respond to the request. And to fulfill that or to get a better feeling what I mean by that, for example, if you're using tools like Uptime Kuma, it's a user-friendly free tool that offers a wide ranges of checks like HTTP, TCP, you can ping a site, you can resolve a DNS name, and so on. And a check and Uptime Kuma may involve regularly pinging a website, like I mentioned, Google or another website, in every few minutes to verify it's available from the outside, measuring the response time and triggering an alert if it's not, showing you the certificate is expired. This is what I mean by the external observability layer and how I try to explain it.
You mentioned the importance of, working with different stakeholders. Different teams within an organization often have varying interests in observability data. Who are the primary stakeholders for external observability, and how does this layer serve their needs?
For the um, external observability, it's a good question. I can only tell you about the stakeholder I deal with it. So in the most time, let me remember it right, there are usually SAR teams that are coming to me who are interested in improving the performance of the application. Like I mentioned, ability, response times, they try to improve it. Then you have something like service product owners that want to understand the overall user experience, particularly how often and for how long user face the access issues or to fulfill the SLAs or something like this. But I also have a lot of contact with the customer support. If you have a service desk, for example, I call it customer support. They want to be staying informated about current outages or performance issues. So, for example, if a customer call or create a ticket, they can react faster. This is the stakeholder I'm working with at this layer the mostly time.
Moving on to the second layer, internal observability seems to be where most traditional monitoring tools operate. Can you elaborate on what this layer covers and the tools typically used?
Yeah, of course. Again, I can try. Focuses on the system-generated logs, like data logs, like logs, metrics, and traces from within the application infrastructure, offering a data view of how services operate and interact. This is for me internal observability. This is the point where I'm define internal observability, and you can, for example, to get you again, I think if I mention some tools, it's going to be easier to follow up from the people. For example, if I'm speaking about metrics, I mean you can use Prometheus for gathering time series data on resources like CPU and memory usage, enabling teams to spot the performance trends. And then if I'm speaking about logs, you can use, for example, Loki as a part of the Grafana stack for collecting and querying log data, enrich them, which helps identify errors and failure in specific services. What application gives you, and also you can using, also for me is internal developer observability, or part of is tracing to follow up. You can use Jaeger, for example, to follow up requests to different services, providing insights into dependencies and latencies issues. So this is how I define the part or the layer of internal observability and these tools I'm using for this part. And the combination of these tools, so if you combine them all, allows you to see, for example, let mention that the CPU is currently high. The logs will show you that there are maybe are currently many requests being processed several times. And then if you are looking at the tracing, you would allow, or the tracing would you allow to see why network packets are being lost. So if you combine all the tools, in my opinion, you have a good observability stack or internal observability stack because it's on the wall stack. And if you are very smart, you put it into a Grafana dashboard, all the working together, and you can see the connection at one glance. And for example, you getting alerting comes in, then you need only to take a look at the dashboard, and it's help you to troubleshoot. As I explained, its example, if the CPU is high, and then you can see in the logs, and then you can see where packages are lost. This is how I define internal, and I think the most people also, if you speak about observability, thinking about this layer.
Tracing is a relatively new concept in the observability space. Some argue that it's just glorified structured logging. What's your take on this? And do you think tracing is necessary if we already have comprehensive logging?
To be honest, I'm not having much experience in this area. As you say, it's very new concept for the mass companies. But from my understanding, while tracing and logging both capture details about application events, tracing offers unique insights into the flow of a request across distributed systems. So making it more than just structured logging, or it was the what you mentioned, I think, structured logging. Unlike logging, which records individual events at specific points, tracing follow a single request and it moves to different services, providing a detailed view of latency and dependency in a chain of a request. This is if so. Let me give you some example, or where I was missing tracing in some projects where the response time, for example, for a service were extremely slow. The slow process could be caused by delays anywhere in the chain. And here you are potentially blind if you don't have traces. At the moment we are very lucky. We found out that it was a checkup process in a shop, if I remember it right. It was we found it about the database logs. We see that the query was written inefficient, and with a new data record, the total response time in the chain was extended. But we are only lucky if we have the possibility to track the request. We will see that the request to the database and the answer increasing if you compare it before the data was put in. So with tracing, it would be easier to identify the root case, and because of that, I think tracing makes a lot of sense. But you would also need a lot of practice and expertise to implement it right in your company.
Data volume is a significant challenge in observability. Some experts suggest that the cost of storing and processing observability data can exceed running the actual application. How do you approach managing this vast amount of data?
I totally agree that it's cost a lot of money and increase a lot of data volume. I have seen this in many projects. Companies collect, for example, metrics and logs over weeks and months, and it's you cost you a lot of money. And for example, the exciting things that I found at the companies is that 95 or part-wise 99% of the logs and metrics are just collected and not useful. I'm asking them question like, what use are metrics from a month ago? Or why is this entire stack logged, but why I can't find the application log, such as accessing from the user I needed to troubleshoot anything? And then if you don't get an answer to such simple question like this, then you usually know, okay, we can compress the metrics or keep them only for 2 or 4 weeks and throw it away, because if the people can say, hey, I'm using the metrics, for example, a month ago or 2 months ago, so you can compress it and throw it away. And if something, so you at this point you can reduce cost, but you can also do things like I have already done twice in a project. I'm separated the application syslogs and the application user logs. The user logs can be kept for several months because you have some regulation to keep it about, I don't know, 3, 5, 4, 6 months or longer. But the syslogs, it's not necessary. The syslogs for the application, not for the system. And so you can throw it away after fewer than 3 months. But you also have to be careful, for example, and to know the domain. If you compare, I'm working for the Hamburg Port Authority for the port, and they have, for example, sensors that measure the water level over metrics. So they provided metrics to measure it, and these metrics are used to draw historical graphs over years. And if you throw them away, you have a problem. So then you must be also try to save them separately and know your domain. So you all metrics are not metrics. This is what I want to say you. In the most cases, metrics like CPU and RAM or utilization, something like this, you can throw away because you don't winning value. If you're asking what a month ago I have increased CPU utilization and so on, but you have something like this, yeah, keep an eye on that.
Given the complexity and potential costs we've discussed, some might argue that comprehensive observability is overkill for smaller teams or projects. Do you think there's a minimum viable observability setup, perhaps just Prometheus and Grafana, that would suffice in these cases?
I completely agree with the statement. The worst thing is when you roll out the entire monitoring stack and nobody use it, and you waste not only a lot of resource but also a lot of money. And this is also a challenge. And every time you implement observability, you will be challenged. And this is why we chose, for example, a label based approach. There are three levels of labels. For example, you have low, medium, and high. With low, for example, you only deploy Grafana and Prometheus stacks, which are enough for many projects and teams and application. And if you, for example, a team needs more like logs and alerting, then we have a label with medium. So if the cluster is labeled with medium, logging over Loki and alerting over Prometheus Alert Manager or another tools will be rolled out. And if only the user need, for example, tracing and understands them, then we put a label high on it. And then, for example, Jaeger will be deployed. This allows you at scale to scale and dynamically adapt the observability stack using GitOps with Argo CD, for example, because you can deploy your stack based on the labels. And this is a really nice approach that's working very well because you only provide for the teams they need it or they understand from the ability point of view. And if they increase their knowledge, you can put another label on it. For example, you are increasing from low to medium, and then they collect the logs. It's working very well. I like the approach. I don't know, maybe someone knows a better approach, but for this was the best one we can get or we can implement.
Now let's move on to the third layer, OS level observability. Some listeners might be unfamiliar with this, so can you explain what this layer involves and its importance in the overall observability strategy?
Yeah, and I think it's okay that only a few reader heard about it or are familiar with this layer, because the most, in my opinion, don't need to know it. But it's good to have heard about it. But the implementation is usually done by certain stakeholders like the platform team or security teams. With this layer, this layer is critical because it provides deep insights into security, resource utilization, and performance at the infrastructure level, helping to detect issues like unauthorized access attempts or optimal system behavior on the host system or on the OS system or on the OS layer. One popular tool for OS level observability I'm using is Falco with eBPF, which allows you for high performance monitoring by attaching to kernel events and capturing detailed information without significantly impacting the system performance. So you don't may put down your nodes because you put a tool on it. So it's working very well, and I like Falco. And the simplest way to explain how it works, I think it's gonna be if a shell is open it inside the container. I think the most of the user already have opening one time in a certification or in a blog, a shell in a container to write to the host file system. Here you should ask yourself why a shell is opening in the container. And more importantly, why does write to the file system? And Falco would recognize this event and then act based on the rules you have established or you have deployed. For example, just only observe or deny. And because of that, I think the most of the people don't heard about this layer or are not familiar with that because they're only user of a platform.
OS level observability seems quite technical. Who are the main stakeholders interested in this layer, and why is it particularly important for their work?
There are usually two stakeholders, maybe more, but two that I'm working with. One of them is platform engineering team, like me, which is responsible for the platform and want to monitor the health and performance and efficiency of the system. And it allows you analyzing the system calls and kernel events so you can identify resource bottlenecks, optimize performance, and ensure the stability of the platform. You can use it for that. This is how we are using it, but you can also argue with that, but the UFSAR teams, they're working like this. Yeah, of course. Similar goals, but the second stakeholder is the security engineering team or DevSecOps, however you want to call them, to protect the company's data and system. They use their OS level observability, like already in the legacy world with VM to spot security threats by tracking system calls and kernel events. This helps them quickly detect suspicious activities like unauthorized access, unusual network connections, or attempting to gain higher access, which could signal potential attacks or vulnerabilities. These are two stakeholders, I think, placed right at the layer.
With the increasing adoption of serverless and managed Kubernetes services, some might argue that OS level observability is becoming less relevant. What's your perspective on this?
It would be nice if a managed Kubernetes solution could cover all of this. As you already say, this is a special topic and requires a lot of necessary skills to fulfill this or to implement them. And if you have a managed Kubernetes solution where you can click on and it's work out of the box, I would really like it. But in the reality, you will need a team to establish a usable ops stack like this. And of course, it's gonna be easier if you have a serverless or managed solution that you only have to provide an endpoint for alerting, and if something happens, you getting a alert and maybe giving a classification of how urgently you should act and the base case what you should do. But unfortunately, the reality is different in my projects. So here you have to decide for yourself and for the company what is important for you and for the company. And because of that, I think it's still relevant. And because you have different managed solutions, maybe in 2, 3 years, it's gonna be a possible way. But you have also a part of customized infrastructure from the customer. And also, if you have a solution that allows you to do this, you need to be able to integrate some custom path regulation. For example, HPR, they are critical infrastructure provider and they have another regulations than other companies, and maybe they have another focus. You need to have API to integrate also their needs into this, and I think it's not easy to integrate it.
We've covered a lot of ground in this conversation regarding this layered approach to observability. As we wrap up, could you summarize why you believe this model particularly benefits Kubernetes environments?
Yes, of course. like I said multiple times, I try. In my opinion, the biggest advantages are that you can talk to different stakeholders and understand their needs better when they talk about observability, just observability. But it also helps you as a developer or platform team to see what gaps you have, what you haven't thought about it, or do we even need it, or something like this. It helps me in my everyday life, and I believe that it could therefore also help others. And because of that, I think it's a nice model to work with it. I never thought about it like a model. I'm introduced as a model, but I never think about it like this. I try just to explain things easier to different stakeholder.
Finally, what advice would you give to those looking to implement or improve their observability strategy? If you were starting from scratch, for example, what tools or stack would you consider for instrumenting and observing a cluster and its applications?
Mhm. The first thing I do for implementing a solid observability strategy, if I getting a new customer, start by clearly defining the observability and business goals and try to match them. So, what do you need to monitor? Why? Who needs the data? Beginning with the basic tool stack that covers all the tree layer is very difficult. So, I think it's easier to start with the internal layer and roll out the Kubernetes stack, for example, because it brings a lot to the table. After that, I would recommend, for example, using tool like Uptime Kuma or Checkly to implement the external observability, or also Kubernetes is bringing something like a black box monitoring, if I remember it right. And finally, I would use tools like FICO to get the OS level ops covered, and think maybe about tracing with Jaeger or something like this. I can only say don't try to solve everything at once. It takes time and skill to deal with the right layers. Successfully set up also does not equal value generated ops stake for your company. So start slow and increase it. I think it's gonna be a good approach to not be overwhelmed.
The last time you joined the podcast, you were in the process of writing a book. Tell us about it.
Yeah, that's right. It was completed and published 2 months ago. It's called Implementing GitOps with Kubernetes, was written by Pietro and me, and tries to cover topics like the one we discovered today or now. And in addition to the many hands-on approach activities in the book, we also try to focus on strongly on the approaches because, tech stacks comes and go and they are deprecated faster than you can publish. So we try also to focus on the approaches and something like to follow up similar approach like clean code, because you're using a language, a programming language, to show how the approaches works. We try to combine them, something like this, and hopefully it helps the reader to understand the things.
What's next for you?
I try at the moment to make more contribution to our open source projects by looking at tools, improving them from the user point of view, and then trying to push them via blogs, because the open source contribution deserve more recognition, in my opinion, and they suffer a lot from big companies, and so it's a difficult field if you are not going paid for the contribution. And so I try to continue to help them or to gain some visibility.
Very good. Last but not least, how can people get in touch with you?
The easiest way is direct message over LinkedIn. It's still LinkedIn.
It worked in our case, so I can speak. I can definitely speak to that from personal experience. Artem, thank you very much for joining us again on Cube FM. Really liked hearing all of your insights. As we mentioned at the very beginning, observability means different things to different people. So I really enjoyed taking a look at this, understanding more about the stakeholders. Keep up the amazing work. We'll be in touch. Take care.
Thank you for having me here. Have a nice day, Bart. Bye.
Cheers. You too.